This is the setup for a design project where we have to build a boat that mimics the propulsive motion of some animal that naturally swims. The design is based on the use of a stepper motor from Soyo. It's a 6-volt 0.8 amp stepper motor. There's a motor control shield from Adafruit. The microcontroller is an Arduino Duemilanove, and the transmitter and receiver are an AM 2-channel transmitter and receiver Ranger in 2 from High Tech. The power system for all of this is 4 AA batteries that powers the receiver, the shield and microcontroller, and the stepper motor through the use of a battery eliminator circuit that's built into the receiver. And let's turn it on. When you flip the switch, nothing happens because the transmitter's off. It's just one of the ways I designed the programming. As soon as you turn the transmitter on, the motor starts flipping back and forth. As soon as you push it forward, the motor's going to spin all the way around and start flapping really quickly. This is to provide forward propulsion. And as soon as you get to where you need to go and you want to go backwards, you just bring it back to middle for the switch, pull it backwards, it'll turn the motor around and start flapping quickly in the opposite direction. Say you want to not turn around but actually go the opposite direction again, just release, press forward one more time, and the motor will flip around and start flapping quickly again. One bug that is in the controlling software that I downloaded to the microcontroller is if you take it from the forward position, release it to the middle, and bring it back to the forward position, the motor will spin all the way around and start flapping again. So the limitation of the current system is you can only transition from the forward motion to the rear motion. Otherwise, the motor will spin around again on you and mess everything up. But that's all there is to it. You turn the transmitter back off, the stepper motor releases, stops moving, and that's all there is to it.